April 5th, 1242. Lake Peipus, on the border of modern-day Russia and Estonia. Thousands of heavily armored Teutonic knights are charging across the frozen lake. They are facing the army of Novgorod. It is a clash of steel, horses, and ambition. But the most important player on this battlefield isn't a soldier. It's the ground beneath their feet. The ice holds them up. Think about that for a second. In almost every other substance in the universe, the solid form is heavier than the liquid form. If this lake were made of frozen alcohol or oil or iron, the solid chunks would have sunk to the bottom long ago. But water is different. Water breaks the rules. If it didn't, those knights wouldn't be fighting on a frozen sheet. They would be swimming. Today on Simple Things Surprising Histories, we are diving into the molecular magic that allows ice to float, and how this one glitch in physics is the only reason life on Earth exists at all. To understand why ice floats, we first have to appreciate how weird water actually is. For 99% of materials, the colder they get, the denser they become. Imagine a crowded dance floor. As the music slows down, people stop moving wildly and pack in tighter and tighter. That is usually how freezing works. The molecules lose energy, huddle together, and the solid sinks because it is heavy and dense. But water follows this rule until it hits a magic number, 4 degrees Celsius, or about 39 degrees Fahrenheit. As water cools down to 4 degrees, it gets denser, just like you'd expect. But the moment it dips below 4 degrees, something strange happens. It stops shrinking and starts expanding. By the time it hits zero and freezes, it is expanded by about 9%. This phenomenon is called anomalous expansion. It's the reason a soda can explodes in your freezer. The ice is literally demanding more space than the water it came from. But why does it expand? The answer lies in a microscopic tug-of-war. Water molecules are shaped like little V's, one oxygen atom holding hands with 2 hydrogen atoms. Because of this shape, they act like tiny magnets. The oxygen side is slightly negative, and the hydrogen side is slightly positive. They attract each other. This is called hydrogen bonding. In liquid water, these molecules are energetic. They're constantly breaking and reforming bonds, sliding past each other in a chaotic, tight jumble. But as water freezes, the molecules slow down. The hydrogen bonds lock them into place. But here's the trick. The bonds force the molecules to hold each other at arm's length. They form a rigid 6-sided crystal structure, a hexagon. This structure has big open gaps in the middle. It's full of empty space. It's like a social distancing rule for molecules. Because of all that empty space in the crystal lattice, ice is significantly lighter, less dense than liquid water, so it rises to the top. This might seem like just a neat chemistry fact, but if water behaved normally, you wouldn't be here to watch this video. Imagine if ice sank. In winter, the ice forming on top of lakes and oceans would drop to the bottom. The liquid water on top would then be exposed to the freezing air, freeze, and sink again. This cycle would continue until the entire lake was a solid block from the bottom up. Aquatic life, fish, plants, microscopic organisms would be crushed or frozen solid. Instead, because ice floats, it forms a shield. That layer of ice on the surface acts as an insulator, like a winter blanket. It traps the heat in the water below, keeping it liquid and relatively warm, usually around that magic 4 degrees Celsius. This creates a thermal refuge where life can survive the harsh winter, waiting for spring. Throughout history, humans have taken advantage of this floating shield in surprising ways. We already mentioned the Teutonic Knights, but let's go to London. During the Little Ice Age between the 17th and 19th centuries, the River Thames froze over 24 times. Because the ice floated and formed a thick, stable crust, Londoners didn't just look at it, they moved onto it. They held famous frost fairs. They set up pubs, shops, and bowling alleys right in the middle of the river. In 1814, they even marched an elephant across the frozen Thames near Blackfriars Bridge. They printed souvenirs on printing presses set up on the ice. It was a carnival that could only exist because of that hexagonal crystal structure holding them up. So, the next time you drop an ice cube into your drink and watch it bob to the surface, remember, you are witnessing a chemical rebellion. You are seeing the unique anomaly that protects our oceans, shaped history, and keeps our planet alive. If you enjoyed this slice of frozen history, hit that like button and subscribe to Simple Things for more stories about the everyday world around us. Thanks for watching, and stay curious.